Hello everyone. In this video, we'll be solving probability exam problems from past paper. The first question, it says here, a 3-digit library identification card is to be printed from the numbers 0 to 5. There are 6 digits here. So we are supposed to make 3-digit identification card in a way that the first digit is non-zero and no number is to be repeated. So how many such cards can be printed? So what to do here? Obviously we have 3 digits, so ones place and tens place and hundreds place. But first of all, the hundred place, it should be non-zero, so we can have 5 chances here. From the 6 digit, from 0, 1, 2, 3, 4, 5, 6, we have 6 digit here. No 6 here until 5. If you count it 1, 2, 3, 4, 5, because the 0 will be counted. So we have 6 digits. So we can have 5 chances because the 0 cannot be taken here. When you go to the tens place now, the 0 cannot be counted. From the 6, 1 digit already taken, consider. So any digit can be taken here. We can include the 0. So we have again 5 chances. In the next part, we do have 4 parts. So when we multiply, it's going to be 100 cards can be prepared. So the answer will be A. Okay, the second question. A student needs to be select 3 books for 3 mathematics, 3 physics and 1 history book. Okay, this student is going to select 3 books, but the total number of books what we have here is 7 books. 3 mathematics book and 3 physics and 1 history are there totally. So totally it's going to be 7 books. Don't forget that. That means he's going to select 3 books. What is the probability that one of the book is mathematics and the other 2 are either physics or history books? Okay, that means one book is math, 3 combination 1, and the other both can be physics, 3,2. This is one way, plus, but still one book mathematics and 1 physics and 1 history it can be. This is math and physics, 2 physics, or math, physics and history, 1 math, 1 physics, 1 history, totally 3 books, or 1 math and 2 physics also. It's possible because either physics or history. Totally what we'll have from 7 we are going to, he's going to select 3 books. That is a total combination. So it is all about combination actually, because selection, in case of arrangement we were using factorials or permutation, but this time it's going to be combination. So first of all, now here 3 combination 1 is the same as 3, and 3 combination 2 also it is 3, and 3 combination 1 it is 3 here, also here it is 3, and 1 combination 1 it's 1. So no need to worry here. 3 times 3, 9, and here also 3 times 3, 9. So 9 plus 9, 18. The above will be, the numerator part will be 18. Now let's focus on the denominator part. When you go to the denominator part, what we have 7 combination 3. How to find this one? It is the same as 7 factorial over 7 minus 3. You know, it's 3 factorial times 4 factorial. Because 7 minus 3 is 4 factorial over 3 factorial, the rule. So 7 factorial means, you know, it is 7 times 6 times 5 times 4 factorial, and keep it. And the down part 3 factorial means 3 times 2 times 4 factorial. Leave it as it is, because it can be cancelled out here. Factorial is 4 factorial, and 3 times 2, you know, it is 6, will be cancelled with the above one. So what remain? 35 remain. Now the numerator part, this is 9, we said already. Product, here also it's 9. Product, 9 and 9. Now 9 plus 9 will be 18, and the denominator part 35, we got it. So the probability will be 18 over 35, which is D, not A, that's D. Okay, next question. The next question, it says items produced by a certain company are subjected to two kind of defect 1 and defect 2. Out the total production, if 5% have defect 1, D1 is equal to 5% given. 5% means it's 0.05, and 10% are defect 2. That means D2 is equal to 10%, which is 0.1, and 2% have both D1 intersection D2, which is 2%. 2% means 0.02. Okay, we have this information. Then what asked? What is the probability of an item for an item that have defect D2, given that it has already defect 1? To be defect 2, remember, it has already defect 1. So we can do this one in different way, but I prefer to do this one using Venn diagram. We have two defects this time. One of it is D1. I can circle it by red 1, and the other one it is D2. I can use blue 1. This is D2, and the first one, this is D1. Now don't forget, the two have intersection part. The intersection part already given to us, that is 0.02. But D1 only D1 means D1 only. How to get it? From 0.05 you can subtract 0.2. 0.05 minus 0.02 if you make, you'll get 0.03. This is 0.03, just D1 only, this part. And the other part is D2 only again. You can get it 0.1 minus 0.02. If you minus, this is 0. By borrowing, it's going to be 0.08. So D2 only means 0.08, this part only. It is, A without B and B without A in case of set. Remember, so this is 0.08. Now, what does it says? The question says, what is the probability for an item that have defect 2, given that it has defect 1 already it's a defect 1, so what the probability to be defect 2? So it has already defect 1 means it is in the red circle, already this circle, it's already here. What is the probability to be in the 0.02, like in the intersection, to fail here? What is the probability to fail in this part? The intersection part is, it's 0.02 over out the total. The total of this red one is 0.05. That means if you cancel the point or the decimal, because after the point, both the numerator and the denominator, they have 2 digits, you can write it 2 over 5. 2 over 5 means, 0.4. So the probability to be defect 1, given that defect 2 to be already given that D1 is 0.04. Once I will repeat it here. Once to repeat this part, let me rub this part once again. The last part, what does it say? The question: what is the probability for an item that has defect 1? Given that, defect 2, sorry. What is the probability that it has defect 2? Already given that D1 means already the item is found in this red circle. Already it is here. But what's the probability to be particularly in this part? It's already, we know it's in the red circle, to be here. This part is 0.02. The whole over 0.05. When you divide it, it will be 0.4. So the probability to be, because the red circle, the whole will be, you can take it as a whole, and to fail, and this part is already 0.02. So 0.02 divided by 0.05 will be 0.4. We can cancel the decimal points. Okay, let's go to the next question. The next question: how many 4-digit even numbers can be formed using the digits 1, 2, 3, 4, and 5 if the numbers start with 3? Okay, 4-digit number: 1, 2, 3, 4. So we have 4 places: unit place, tens place, hundred, and thousand place. Don't forget, the number must be even. So the unit digit cannot be odd number. We can have two chance here, 2 and 4 can be written. So here we can have two chance, and the number should start with 3, means here we have only one chance in the thousand place. But the other, we can take any of the number 5 digit we have, because we can repeat. It doesn't say, the question is not restricted. If it says no need to repeat, or you can use the digit at most once, we may reduce. But the middle part, the 100 in the tens place, it can take any number. So 5 chance we have. But the unit place, we have 2 chance, because only 2 digit numbers are even. To make the number is even number, this is a chance. And the thousand place, it must be only 1 digit we have, that is 3. So when you multiply 5 times 5, 50 times, 25 times 2 will be 50. So the answer will be B. Okay. Again, the next question. A committee consisting of 3 students is to be selected from 10 candidates, among which 4 girls. Obviously, if the 4 girls and the 6 will be boys. What's the probability at least 1 girl is selected? 3 to be selected. So what's the probability at least 1 girl? Means 2 girls okay, 3 girls also okay. So 1 girl and 2 boys, 1 possibility. The other possibility, 2 girls and 1 boy. This is the second possibility. Plus the third possibility is all of them are girls. You see the way of selection, this is combination. Selection means combination. There are 4 girls and 6 boys. So what is the probability to be at least 1 girl? Means 1 girl and 2 boys, it's okay. Or at least 1 girl. 2 girls and 1 boy, it's fine. Again, all of the 3 can be girls. The total number of students what we have is 10 to 3. So this time, take care. 4 combination 1, it's the same as 4. And 6 combination 1 also it is just 6. And 4 combination 3 also it is just 4. 4 combination 2 and 6 combination 2 and 10 combination 3 must be done. So we can do it somewhere else and bring the final result here. First of all, let us do 6 combination 2. 6 combination 2 means, it is 6 factorial over 6 minus 2 will be 4 factorial times 2 factorial, which is 6 times 5 times 4 factorial, the whole over 4 factorial times 2. 2 factorial means 2. So cancel here 4 factorial with 4 factorial. And by 2, 1, this by 2, 3. 3 times 5 will be 15. Okay. Again, 4 combination 2, the same way. Is the same as 4 factorial over 4 minus 2 will be 2 factorial times 2 factorial, which means 4 times 3 times 2, the whole over 2 times 2. 2 times 2 is 4. You can cancel the 4, so finally it will be 6. And the last one, 10 combination 3. This is the same as 10 factorial over 10 minus 3 will be 7 factorial times 3 factorial, which is 10 times 9 times 8 times 7 factorial. Keep it here. And the down part, 7 factorial as it is, multiply with 3 times 2. 3 factorial means 3 times 2. And then when we simplify here, 7 will be cancelled with 7. And by 3, 1, this by 3, 3. And by 2, 1, this by 2, 4. 4 times 3 will be 12 times 10, 120. So when you get back, this one we got it 15. And here we got it 6. And the down part we got it 120. Okay, now let's finalize. 4 times 15 will be 60, plus 6 times 6 will be 36, plus 4, the whole over 120. 36 plus 4 will be 40, plus 60, 100. 100 over 120. You can cancel the 0. And then by 2, 5 over 6. You can simplify. So the answer should be A. Okay. Next question. This time it is a group of 6 students taken their seats at random in a round table for discussion. What is the probability that the two specific students do not sit together? First of all, total arrangement without considering the two specific, since it's circular arrangement, it must be 6 minus 1, which is 5 factorial. We have to do it. This is a total arrangement without considering the two students are sitting or no sitting. It is 5 factorial. This means 120 ways we do have. But what if the two students are sitting together? That means the two students, if they are sitting together, consider in a circular arrangement, we have 6 place 1, 2. Okay. 1, 2, 3, 4, 5. Let us divide this part equally. Okay, let's do it. So we have 6 arrangement. From the 6, what if the two boys are sitting together? The question says if they are not sitting together. If the two boys are sitting together, first of all, for them, they can exchange place. B1 and B2, let's consider them. So we have 2 factorial this time for the two boys only. If they are sitting together means we can count them as 1, but they can exchange place. So 2 factorial we have. The others, they can change place. That means multiply by 4 factorial, total arrangement. So it's going to be 2 times 4 times 3 times 2. 2 factorial means just 2, and 4 factorial means this one. So when you multiply 4, 3, 12, 24, 48. 48 arrangement we have. So sitting together, we are doing sitting together. Sitting together for the two boys will be 48 over 120 opportunities we have, or chances. Let's simplify. When you simplify, you can simplify by 12 the up and the down. By 12, this will be 4. The down one by 12, it will be 10. That is 0.4 chance. This is just for let them sitting together, the two boys. What if they are not sitting together? That means not sitting. I can say no sitting together. This will be 1 minus the sitting together. 1 minus 0.4, which will be 0.6. Because the total probability, obviously, total probability is 1. So if sitting together is 0.4 chance, what will be no sitting? 0.04. That's going to be 0.6. 6 over 10, that means 6 over 10 means, when you simplify, 3 over 5. So the answer will be A. Once I will repeat. Since it is a circular arrangement, the total number of arrangement will be 6 minus 1 factorial. In case of a circular arrangement, n minus 1 factorial will be the total arrangement. So that means 5 factorial, which will be 120 total possibilities we have. But this time, two boys cannot sit together, it says. So we took the two boys are B1 and B2. So if they are sitting together, the other boys, the 4 boys, they have 4 factorial arrangement they do have, but the two boys, they have only 2 factorial. If they are sitting together, they can exchange place, of course. So 2 factorial times 4 factorial will be 48 possibilities are there. So the total possibility or probability of the two boys letting them two sitting together, 48 over 120. When you simplify and change into decimal, it will be 0.4. This 0.4, take care. The total probability of letting them sit together, the two boys. But the question is says do not sit together. That means we have to subtract 1 minus this result, because the total probability is 1. 1 minus 0.4 will be 0.6, which is 3 over 5. The answer will be A. A very interesting question. The next question, it says a box contains 5 white, 6 red, and 4 black of identical size. If 3 balls are randomly taken out from the box, one after the other, remember, one after the other, what is the probability that the first ball is white and both the second and the third are red? So what to do? What is the probability that the first ball is white and both the second and the third will be red, one after. Okay, what we can do here again, the first to be white will be 5 chance we have out of the total. The total will be added, which will be 15. Now the next to be red, we have 6 chance, but out of how many? Not 50, it must be 14, because one board already taken. Consider one board already taken. And the next one, the next probability will be again still the second and the third is red. So one red consider it's taken, so we have 5 chance out of 13. This time try to observe the denominators. The denominator is decreasing by 1, each of them, because one after the other means when you take one, the total number will be reducing by 1. So in first case it's white ball, so 5 chance we have 5 over 15. In the second case, the second ball must be red, so red already it was considered 6 red balls we had, so that 6 over the total number now already 14 times. Now in the next case the number of red also it's reducing. So let us try to simplify here. This by 5 1, this by 5 3. Okay, next again by 3 1, this by 3 2. Very good. Again by 2 1, this by 2 7. Now let's multiply. When you multiply the upper part, 5 times 1, which will be 5 remain. The down part, nothing left, 7 times 13 left. When you multiply 7 times 3 21, you have 2 in your mind. 7 times 1 7 plus 2 will be 90. So 5 over 91, the answer will be D. That's the way how to solve some probability problems from exam papers of previous years. So hopefully I will continue with another video. Thank you for watching. Don't forget to subscribe, share and comment.